Everyone's heard it. ICP is going to zero. It's a claim that's been repeated so many times, it almost sounds like a fact. But what if that entire narrative is based on misunderstanding? Today, we're pulling back the curtain on the internet computer's most controversial topic. It's tokenomics. Because behind all the confusion, price charts, and memes, there's a real story that almost no one is telling. In this video, we're breaking down where the zero idea actually came from, what people got wrong about ICP's design, and how its economic system might be one of the smartest, not the weakest, in the entire crypto space. So before you make up your mind about ICP, watch this till the end. What you'll learn here might completely change how you see this project. This video is created for educational and informational purposes only. It does not promote or endorse any financial product, investment, or cryptocurrency. All information presented here is based on publicly available sources and independent analysis. Viewers are encouraged to conduct their own research before making any financial or technological decisions. For a long time now, the internet computer has been one of the most polarizing projects in the crypto space. Some see it as the most ambitious blockchain ever built, a complete decentralized alternative to cloud infrastructure. Others, however, dismiss it as an overhyped experiment that's destined to fail, often pointing to its so-called zero narrative as proof that its tokenomics are broken. But what does that zero narrative actually mean? Is it really a fatal flaw in ICP's design? Or is it just another misunderstood aspect of one of the most complex blockchain architectures ever created? In this breakdown, we're diving deep into ICP's tokenomics, exploring where the zero idea comes from, why so many critics get it wrong, and what the real economic design behind the internet computer actually looks like. Understanding where the zero narrative comes from to start, the zero narrative began spreading during the market downturn that followed ICP's explosive launch in 2021. When the token first hit exchanges, it was valued at hundreds of dollars per coin. Within months, it crashed by more than 95%, and that brutal decline became the foundation of a narrative that ICP was a token destined to trend toward zero. Critics argued that the supply dynamics were unsustainable. They pointed to neuron rewards, the NNS, network nervous system voting model, and ongoing minting as evidence that ICP would be perpetually inflated. They claimed the project's economics allowed too many tokens to flood the market, driving its price down forever. And when price action lined up with that view, it was easy for people to assume the narrative was true. But that's only part of the story. Because to really understand ICP's tokenomics, you need to go beyond surface-level assumptions and look closely at how the internet computer's economy is structured. The dual purpose of ICP, governance and resource. ICP isn't a token that exists just for speculation or transactions. It serves two foundational purposes inside the network: governance and resource management. On one side, ICP powers the governance layer through the network nervous system, NNS, the decentralized DAO that runs the entire internet computer. Token holders can lock their ICP into neurons, which give them the right to vote on proposals, protocol updates, and even funding allocations for subnet upgrades or new features. In return for participating in governance, neuron holders receive rewards. That's where one part of the zero narrative originates. Because these rewards are minted over time, critics view them as inflationary. But here's the other half of the design that most people ignore. ICP is also used to pay for computational resources on the network. When developers deploy smart contracts, called canisters, they convert ICP into cycles, a stable resource token that powers computation, storage, and bandwidth. Once ICP is converted into cycles, those tokens are burned, permanently removed from circulation. This creates a natural deflationary counterforce to the neuron reward emissions. The more developers build, the more ICP is burned, directly linking the network's economic health to its adoption level. So, while critics only focus on the minting side, the burning mechanism is equally important, and it's what keeps the system balanced over the long term. Minting versus burning. The balancing act. Let's simplify this into two flows: minting from governance rewards and burning from network usage. The internet computer continuously mints ICP to reward neuron participants. However, it also burns ICP every time developers convert tokens into cycles to run their canisters. At any point in time, the total token supply depends on which side outweighs the other. If network usage increases faster than governance rewards, ICP can become deflationary. If the opposite happens, it temporarily trends inflationary. This design gives ICP something extremely rare among crypto networks, a self-balancing economic model that directly ties token value to real network demand. It's not a static system like many Layer 1 tokens where emissions are pre-programmed and irreversible. ICP's tokenomics are dynamic, designed to evolve based on usage, participation, and growth of the ecosystem. That's a concept a lot of critics overlook. They assume the minting process is endless and disconnected from burn activity. But in practice, the balance between creation and destruction of tokens defines the long-term economic trajectory. The psychology behind the zero label. So, why did the zero label stick so strongly in the first place? Partly it's because people confuse short-term market performance with fundamental design. When ICP's price fell hard after launch, it created a psychological bias. Investors equated price collapse with broken tokenomics, even though the two aren't necessarily linked. Another factor is the complexity of ICP's architecture itself. Most tokens have simple supply models, a fixed cap, predictable halving, or steady inflation. ICP's multi-layered structure with neurons, cycles, and the nfts makes it far harder to explain in a tweet or headline. Complex systems often get misrepresented, and that's exactly what happened here. The zero meme became an oversimplified version of a very nuanced reality. But markets have a way of maturing. Over time, as projects deliver real utility, the truth about tokenomics tends to surface. The role of neurons in the economic loop. One of the most unique parts of ICP's design is the neuron system. When a holder locks ICP into a neuron, they're essentially removing it from circulation. Depending on the lockup duration, those tokens can't be sold for months or even years. This process reduces liquid supply, which has an anti-inflationary effect. While rewards increase total supply, staking through neurons counteracts that by locking up large amounts of ICP. And the longer those neurons stay locked, the more governance weight and rewards they generate. That creates a strong incentive to think long-term, aligning token holders with the future health of the network instead of short-term price moves. It's a delicate but intentional balance, inflation through minting, offset by both burning and staking lockups. When viewed holistically, it's a circular economy where value constantly flows between governance, computation, and real utility, not a one-way path toward zero. Real-world utility. The missing context. Here's the part of ICP that rarely gets discussed in the zero debate: real usage. The Internet computer isn't just a blockchain for token swaps or NFTs, it's an entire decentralized cloud infrastructure capable of hosting websites, dApps, AI models, and enterprise software directly on-chain. Every new canister deployed represents ICP being burned for computation. As more developers build on the network, whether it's social apps like OpenChat, DeFi protocols, or decentralized AI integrations, the burning rate increases. That means utility itself acts as the ultimate price stabilizer. The more demand there is for computation, the more ICP is removed from circulation, directly countering reward emissions. This is where the tokenomics model begins to make sense. The system is designed to reward governance and development simultaneously, ensuring both network security and growth. It's not broken, it's just sophisticated. Comparing ICP to traditional blockchains. To really appreciate this model, it helps to compare it with other Layer 1s. Take Ethereum, for example. ETH's EIP 1559 mechanism burns a portion of transaction fees, creating a deflationary pressure. But ETH doesn't directly link its burn rate to resource usage. It's tied to transaction demand. In contrast, ICP burns tokens based on computational usage, not just transactions. Every function call, every canister update, and every piece of stored data consumes cycles, meaning real activity translates into token destruction. Similarly, Bitcoin has a fixed supply, but it doesn't inherently respond to network usage. Its scarcity is artificial, pre-coded, and static. ICP's scarcity, on the other hand, is adaptive. It reflects actual utilization of the network. This dynamic model is closer to how real-world economies function, balancing inflation, rewards, with consumption, burns. That's what gives ICP's tokenomics long-term sustainability, even if it's harder to grasp initially. Long-term sustainability and developer incentives. Another overlooked strength of ICP's tokenomics is how it aligns incentives between developers, governance participants, and users. Developers need cycles to deploy and maintain applications. They're directly motivated to buy ICP to fuel their projects. At the same time, neuron holders earn governance rewards by maintaining network stability. This dual-sided system ensures a continuous feedback loop between usage and governance. The more apps that go live, the more cycles get consumed, and the stronger the burn mechanism becomes. In essence, ICP's tokenomics create a closed economic loop where every participant contributes to both utility and value retention. That's the opposite of a system trending toward zero. Data trends. What the numbers reveal. While narratives drive short-term opinions, data tells the truth. In recent months, the Internet computer's ecosystem has seen consistent growth in active canisters, deployed applications, and burned ICP. The number of active neurons also continues to rise, signaling deeper community participation. Each of these indicators points toward a maturing economy, one where the feedback loop between governance and usage is working as intended. The zero narrative loses credibility the moment real data enters the picture, because no network trending toward zero simultaneously grows in both governance participation and developer adoption. The role of transparency. ICP's architecture is transparent by design. The NNS dashboard publicly displays neuron activity, locked tokens, proposals, and cycle burn data. Anyone can see exactly how much ICP is being created and destroyed at any given time. This level of openness makes it difficult to sustain misinformation. Over time, as more people explore the NNS directly, the tokenomics becomes self-evident. In a sense, the system doesn't need to defend itself. It's all visible on-chain. The only barrier is understanding. Market perception versus structural reality. The market often reacts faster than it understands. That's what happened to ICP in its early years. Complex technology met simple assumptions, and the result was confusion. But as the noise fades, structural realities emerge. ICP's network continues to expand, canister count increases, and partnerships with AI and DeFi projects grow steadily. Each of those developments represents ongoing token burns, the invisible economic counterweight to reward emissions. So when critics talk about ICP trending towards zero, they're focusing on surface-level metrics, not the deeper structural design. Why the zero narrative persists? Even with all this clarity, the narrative persists, mainly because it's emotionally appealing. Zero is a simple, powerful word that fits perfectly into bearish sentiment. But simplicity doesn't equal accuracy. Complex systems like ICP can't be reduced to a single number or meme. The same complexity that fuels misunderstanding is also what makes ICP unique among blockchains. As the ecosystem matures and more developers build on it, that misunderstanding will naturally fade, replaced by observable economic balance between governance rewards and burn rates. Looking ahead, the next phase of ICP's economy. The next phase of ICP's evolution involves scaling its service nervous systems, SNS, decentralized DAOs for individual dApps. Each SNS introduces new governance and economic activity, increasing demand for cycles and further accelerating token burns. In other words, the more projects decentralize through SNS, the stronger the deflationary mechanism becomes. This shift will redefine ICP's overall economy, transitioning from a single governance structure to a federation of autonomous systems, all consuming ICP for operations. In that world, the zero narrative doesn't just collapse, it becomes obsolete. The Internet computer's tokenomics aren't perfect, but they're far from broken. The zero narrative thrives on misunderstanding, not math. ICP's economic model is complex because it was designed for a complex network, one capable of running the entire Internet natively on-chain. Its balance between minting, burning, and staking isn't a bug. It's a feature built to ensure longevity and adaptability. Over time, as adoption grows, the system will naturally find equilibrium, driven not by hype or speculation, but by real computational demand. So the next time someone says ICP is going to zero, remember this: narratives fade, but utility doesn't. The Internet computer's value isn't just in its price, it's in what it makes possible. And that's something no meme can erase. All right, if you learned something new or enjoyed this video, Make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.